Welcome to the webcast AnyGait, a powerful gait lab application to process motion capture trials. My name is al-munajjed. I'm here with Arne Kies and Søren Torholm. They will support me, and I'm your presenter for today. Very briefly, I'm going to start to tell you who is AnyBody. Then I'm going to explain the AnyBody Modeling System. Then I will go to the key point today. I will explain the Gait application called AnyGait. I will show some examples how to use this application. And then finally, we will have time for some questions and answers. If you have any questions in between, there is Arne and Søren. They will answer those questions in between. You will have to your right a small dialog box with the header questions, so you can type in your questions in there, and Søren or Arne will answer them immediately, or we will wait to the end and I will try to answer your questions live for you. Very briefly, AnyBody Technology is a spin-off company out of Aalborg University, founded in 2002. AnyBody Technology provides software licenses for the AnyBody Modeling System, but we also provide consulting, training, and support. And since this year, 2012, we have this new model called AnyGait, which is a special model for gait labs. So AnyBody is a multi-body system made for musculoskeletal modeling. It's a self-contained system. That means it does not need any third-party software except from Windows. It has several interfaces, so you can read in motion and external forces from motion capture systems. You can read in bone and muscle data of subjects from image processing softwares. You can import any cut files in a STL format, and you can export all complex loading scenarios into finite element softwares. And of course, there's an interface to Office systems. The AnyBody Modeling System has an open body model. That means the body model that is used in the system is no black box. It's accessible in every detail. So if you want to adapt the body model to your specific needs, you can do that. You can change each bone segment, joint, muscle attachment point. There's a broad and deep model validation done either by us or by our many users, and there are several publications out in the literature where you can see validation examples. The system has also an API for embedded use. Here you see a screenshot of the full body model in the middle and some details surround. The model is by far the most sophisticated model of this category. It includes all bones and all skeletal muscle branches in the body. And for some body parts where fundamental data on properties are available, it includes also ligaments. The bones are modeled as a rigid body. Muscles act as sophisticated actuators pulling on these bones, and ligaments are modeled as nonlinear springs. The basic flow is simple. AnyBody takes in motion and external forces as input, sets up the equilibrium equation, and finds the individual muscle forces needed to create this motion. So the standard model is roughly average European male. However, the model is very easy adaptable to your specific needs. So you can adjust body size and shape using different heights and weights. You can use subject-specific scaling, entering different segment lengths of tibia, femur, for example. You can also exchange the bones used in the standard model and use patient or subject-specific bones, and therefore also change the muscle attachment points to these new bones. You can also model surgical effects by removing muscles or reducing the maximum strength of these muscles or ligaments. If you use motion capture data, as you see here in the right hand picture, the model will scale the body model automatically so that the body model fits the subject recorded in the Gait lab. Here you see an example of how this will look then. So we use motion from a motion trial and external forces from force plates as input. You see, for example, the red dots here are the markers from a motion capture trial, and then the force plates with ground reaction forces as input, and then we use inverse dynamics with a muscle recruitment solver to calculate muscle forces. Here you see the muscle forces visualized where they act. So you see here these blue and red lines representing the muscle forces, blue and red either in muscle origin or insertion point, and you can make this graphical visible in the model view, or you can also get all those values, muscle forces, muscle activations during the activity that you analyze in a graph or in a table. So the AnyBody modeling system can then be used for many different applications. So for example, it's used in product design optimization. So there are these optimization studies to get, for example, you see here a picture of a wheelchair. So you can make an optimization study to find the optimal position of the axis of a wheelchair to get the lowest joint reaction forces in the shoulder, for example. But this can also be done for different products as bicycles or whatever you can imagine. The AnyBody modeling system can also be used for an ergonomic analysis and documentation, for example, ingress and egress out of a sports car, as you can see here on the right hand. It can also be used for any kind of pre-op planning, post-op evaluation, or failure analysis in the orthopedic sector. Here you see a graph of a spinal fixation device, or you can use it for hip replacements, knee replacements, or any similar case. The last field here is you can export all these complex loading scenarios on bones or on devices and import them into finite element analysis. So for example, here you see during Gait or during different activities, you can export the loads acting on a femur and analyze them in a FE tool. So now I will start to explain the AnyGait, and the title again was a powerful Gait lab application to process motion capture files. So AnyGait is an easy-to-use model to analyze motion capture files, especially in a Gait lab or in a clinical environment. It is a Gait application including all major muscle fascicles, and it's predefined. However, it's still highly adaptable to fit specific needs of your Gait lab in terms of Gait lab setup or patient group or whatever you want to analyze. We have introduced a new graphical user interface to enable easy processing of motion capture trials, and therefore there is no need for modeling or programming skills of the user. Once again, it's a predefined model, however it's still adaptable to your specific needs. So you can change even this graphical user interface. AnyGait uses C3D files, including force plate data, as input. There are several predefined and ready-to-use formats from most motion capture systems. However, it is adaptable to almost any kind of setup. So if you have a setup that is not predefined, you or we can help you with setting your new motion capture system up. As output, there are important results are displayed in an easy-to-read form. However, AnyGait is running inside the AnyBody modeling system, so all features and results that are usually displayed in the AnyBody modeling system are also available in AnyGait. So now I'm going to switch and give you a live demo of the model. In the repository that comes with the AnyBody modeling system, if you go in there, you will have under Applications a folder called AnyGait. If you go in there, we will have a small manual describing on how to use AnyGait here, and then we have this file anygait.main.any, and I'm starting this here now, and it tells me please click Operation Load Model, so I will load the model, and now I have loaded this graphical user interface. I'm going to minimize this area and increase the size of the middle part here. So this here is pretty much the description view of, and it always tells you what to do. And here, similar to previous models, we have the project tasks. So first, you have the chance here to start a new project. So we will type in a new project name. I'm going to call that test. Then I'm going to click Save Project Name, and then I'm going to load the model. So you see something happened. We switched to a different view. First of all, you see now we are in the current project called test. And it tells you here, please click on Load Model and then enter the project-specific data. So we load the model, and then we have here in this window several values to define the model. So in our case, there is always going to be a standard weight and height of the subject. In our case, the C3D file that I want to show you now, demonstrate now, our subject has 70 kilo and is 1 meter 86. So you have to enter the height in meters, 1.86. So we have here a browse button. We need for the model a static C3D file and a dynamic C3D file. So we will browse now, and I'm already in the right folder, but in the repository under AnyGait you will have a folder called example data, and if you go in there we have a standing reference, meaning this is the static, and we have a dynamic C3D file called slow run. So in the next fields you can define the start frame number and the last frame number that you want to analyze. If you don't know that, and if you leave those two fields blank, then originally the start and end frame of the C3D will be used. So I'm not typing in anything there now. Then you have two fields to define a marker prefix for the dynamic and for the static trial. In our case, here with these C3D files, we don't need them. But in several systems, sometimes in Vicon, for example, you can have the marker names, you can have them a little bit different with a prefix of the trial name, for example. So in the next 4 fields, you can define the events heel strike and toe off for right and left foot. If you leave it blank, they are not, or 0, then they are not going to be used. So I'm leaving everything blank here now. I click on Save Values, and then I proceed to process pre-processing. When I load pre-processing, then I go to pre-processing run. Then I see here what I typed in before. So first of all, weight of the subject is 70 kilo as specified before. Height is 1 meter 86. So the C3D file you see here, it starts at frame 106, it ends at 203. We did not specify anything else, so we selected 106 and 203. Here I can open now the model view by clicking on Set Task View. I'm going to increase that window, and I can rotate the model view, and in here now you see a stick figure. So in pre-processing we are running the kinematics of the model, and for the kinematics, to make it quick and still precise, we are using a stick figure. So if I click now on Execute Task, we see the stick figure running the same way as the motion capture trial. So the stick figure is adapted from the stick figure that you may know from Vicon, for example. So we have run and exported now the kinematics, and we will proceed now to the real processing where we perform the inverse dynamics. So first I go to processing load. I load the model, and it tells me here already loading this step will take some seconds. So what happens in here is we are scaling the body model, the AnyBody body model, according to the dimensions of the stick figures of the stick figure, and the stick figure is using the markers. So it has the dimensions of the subject from the MoCap trial. So usually that takes a couple of seconds, yes, and you see in here we have the body model in there. So for now we only have the lower extremities in there because we were looking only at the lower extremities in this model. So if I go now to processing run, we have once again a table in here of the values that we typed in. However, most of them are 0 because we did not define heel strike and toe off, for example. So task view is open already, so I can click on Execute Task. And in here, now you see the body model is over the stick figure, and it is performing the slow run that we have seen on the stick figure before from the MoCap trial. So I rotate it a little bit, that you see the body model from the side. And now any second we will have the first contact here, and we will see the ground reaction forces displayed with a blue bar. Here we see it. And we already have 21 out of 96 steps. So this is a very quick model. While it's running through, I'm going to show you something else. Here in the project task, we have also some results predefined. So if you go into output, here we have right hip forces, right knee, ankle forces, and the same for left hip, knee, and ankle. So if I click now on right hip forces, we see here open new chart view. So I can open a new chart, going to increase the size, and here we already have the joint reaction force in the right hip in X, Y, Z direction. And I can do the same for the left side. Either I can open a new chart or I can change the existing chart displaying the left hip force. So the experienced user of you will know that there are a lot more results available in the AnyBody modeling system. So if we go deeper into the model, under human model, body model, we still have all the data in there. For example, if we go to right, leg, muscles, so you see here this huge list of muscles that we have in the model, and let's choose randomly. I didn't even look what it is. It's gluteus minimus anterior. So you can display the activation profile of this gluteus minimus anterior for this activity that we analyze at the moment. I can do that for many other types of muscles as well. Let's go to a quadratus femoris activation here. You see this one is already activated at a later point compared to the previous muscle that we looked here. So finally, I go back to the model view, and you see we already finished 96 of 96 steps. Model is finished. Then I go show you quick. We have in the folder AnyGait a folder called projects. If you go in there, when you create a new project, you will automatically create a new folder. So ours was called test here. In there you have a setup file where all the subject-specific values are saved. We have the dynamic and the static C2D files that will be renamed automatically in dyne and stat. We have a GCD file, so this is a gait cycle data file that can be opened in Vicon Polygon, for example. However, you need to have it defined the toe off and heel strike for that, which we did not do in this case. And you will also have a text file called results in there. I can open that quick. And in there you have all the reaction forces, the joint reaction forces, and you can open these files in Excel, for example, in MATLAB or SPSS, depending on where you do your post-processing, for example. However, you can also export all those graphs as images or as text files separately. So I'm going to switch back to my PowerPoint presentation quick. Here you see the marker names that are used. In the predefined model that you will find in the repository, we used a MoCap trial recorded with a Qualysis system, and these are the marker names used in this trial. However, there's a switch in the model if you want to use the typical Vicon names, or even we have a switch to use SIMI protocol. And about the markers here, for a more precise analysis and for more precise results, we are using medial ankle and knee markers additional to the plugin Gait protocol. Now I promised you also some examples of early stage users, just to show you that the model is capable of all the traditional things that are used in the AnyBody modeling system before. So you can include the finite element export function in there as well. So if you analyze during gait or stair climbing and you want to know the exact loads on the femur with a hip replacement device in there, you can do that. This is here now a screenshot from ANSYS with the von Mises stress distribution in there. And here in the middle image, here you see the femur with the hip device in there, and here you see all the muscles attachment points that create forces. And you see they are applied a little bit outside of the muscle, and then with this so-called spider web they are distributed on an area on the bone. Another study is recently published or accepted from a group from Germany, shows that you can do analyze the hip replacements with subject-specific hip joint loading. Or from a group here in Aalborg and in Oxford in the United Kingdom. This is a study they have used this model before to analyze patient-specific motion, also with hip replacement devices, looking at rim loading during these gait cycles, and looking at wear in the hip joint or in the device. So I'm already at my end. My final remarks are AnyGait is a powerful model to analyze motion capture trials in a gait lab or clinical environment. It has a predefined GUI that makes it easy to use, but still it's highly adaptable to fit specific needs of your gait lab. And in a few minutes you will get from a C3D file joint reaction forces and muscle activations. So before I stop, I will try to answer some questions now. You will find more information about AnyBody, the AnyBody Modeling System and AnyGait on these in the internet, either on anybodytech.com or on anyscript.org. This is a homepage of the AnyBody Society, so all the users have a forum and a wiki there where information, experience can be exchanged. There will be another webcast soon in a couple of weeks focusing on the latest release of version 5.2, and of course we are present at some conferences in July, for example, in the 3D analysis of human movement in Bologna, at the ASB in August in Florida, and we will be at ESMAC in Stockholm, Sweden in September. So thank you for attention so far, and I'm trying to get some questions from my colleagues here and try to answer them.